What if AI could read its own mind and fix what it finds? When the biggest barrier isn't the AI itself, but the code surrounding it, one system rewrote the rules entirely. The results will surprise you. For years, we believed the limit of artificial intelligence was the size of its brain. But what if the real cage isn't the AI itself, but the very code we wrote to contain it? The truth about MetaHarness is that it marks the end of the human-led era. AI is no longer just processing data. It is now redesigning the very digital machinery that allows it to function. Think of a large language model as a genius brain. But a brain without a body can't act. The harness is that body, the Python code that tells the AI how to remember things and use tools. This infrastructure manages the LLM's state, its retrieval strategies, and its interaction with the outside world. Until now, every line of this critical harness code has been painstakingly written by human engineers. We are now in the end of the trial and error era. Human-written infrastructure has become the primary performance bottleneck because our manual coding logic is riddled with inefficiencies that we can't even see. Advanced AI models are effectively trapped inside inefficient human-built wrappers. We try to fix them with simple scores, but we're essentially trying to tune a jet engine with a hammer and a blindfold. Most optimizers use scalar scores, a simple pass or fail. But a single number doesn't tell you why the AI failed. It hides the root cause deep within the execution logs. This lossy feedback creates a massive information gap. If an AI fails a math problem, was it because it forgot a number, or because the human-written memory retrieval code fetched the wrong document? Humans simply cannot process 10 million tokens of raw execution traces to find a single logic bug. It's like trying to find one specific grain of sand in a desert during a windstorm. But MetaHarness can. By analyzing these raw logs instead of textual summaries, the AI gains a 16% performance boost. It sees the exact moment its retrieval strategy or memory management faltered. Causal debugging is the holy grail of software engineering. It means not just knowing something is broken, but understanding the chain of cause and effect that led to the error. MetaHarness reads its own thoughts and execution traces to identify specific logic errors in how it retrieves information. It doesn't just guess. It knows exactly which line of Python code is the culprit. This is where the meta in MetaHarness comes in. The system uses an Agentic Proposer, an autonomous agent that takes the debugging insights and uses real terminal tools to rewrite the infrastructure. It's not just suggesting code. It's executing it, testing it, and refining it in a closed loop. It builds a new, optimized harness that is perfectly tailored to the AI's specific reasoning patterns. The numbers are staggering. In a text classification task, MetaHarness achieved a 7.7-point gain in accuracy while simultaneously using 75% fewer context tokens than the human design system. It officially outperformed humans in classification, math, and coding. It even set a new world record on the Terminal Bench 2 coding benchmark, proving that AI is now a better architect of its own house than we are. We have reached the climax of AI development. The biggest bottleneck is no longer the model's weights, but the human-written harness code that manages it. How has MetaHarness fundamentally changed the game? In a landmark 2026 study, researchers revealed that an autonomous AI engineer can rewrite its own infrastructure to outperform human design systems while using 75% fewer context tokens. By analyzing raw execution traces, MetaHarness marks the transition from manual prompt engineering to self-assembling AI machinery. If AI can engineer its own infrastructure better than we can, where does that leave the human engineer? Are we being written out of the script, or are we being promoted? We are witnessing the birth of self-assembling machinery. While the compute tax means only top labs can afford this now, the future belongs to those who can oversee these self-evolving systems. We are no longer the builders. We are the lead architects of an intelligence that builds itself. We started by asking, MetaHarness, how AI is learning to engineer its own infrastructure, and the answer: The biggest bottleneck in AI performance is no longer the model's weights, but the human-written harness code that manages it. In a landmark 2026 study, researchers revealed that an autonomous AI engineer can rewrite its own infrastructure to outperform human-designed systems while using 75% fewer context tokens. If this changed how you see things, share it with someone who needs to hear it.